Did I put the Nearpod in the link? I don't think I did I? I got distracted reading all of the fun new slang terms. All right, let's see. I am going to put the new Nearpod link into the chat. Okay, paste. Okay, so there is the Nearpod, and this one's gonna be student paced, and I did that so that way if you guys want to finish it, you will get extra credit. So today we are going to do rule number 8 and rule number 9. I've been able to get through those with all the other classes, so I'm sure we'll be able to, because you guys, this period 6, you guys are usually like my group that gets the most done. I do have one group that's ahead of you guys, surprisingly. Period, what is it? Today's even day 5, right? They got ahead, like way ahead. We got up to rule 12 yesterday. But with that said, everyone else, if you finish up to rule 12, I'll post the YouTube to our class channel, so you can get all the writing part down. I'll even put the I'll go over the guided practices, and you guys can get extra credit for that. Make sure that you finish it though by Monday, because grades are due. So next week we won't be doing any classwork. We're going to be watching a movie. That's why you guys have popcorn, and we'll just be going over any missing work if you want to, if on Monday, and then during the class, if you guys do want to like learn a little bit more, I'll have an extra room open, but we'll just be watching movies. So your last chance to get any extra credit is going to be this weekend. So there's this Nearpod. You can finish the Nearpod, go up to rule 12, or there was a couple extra credit worksheets that were out and about. Don't forget, most of you guys still have not finished your Ed site, so make sure you get that done. Okay, what else? I think that's it. So what I'm going to do is I'm going to switch cameras now, so that way you guys can see my document camera, the page, and we're going to go over today. We're going to learn how to multiply rational numbers with the same sign. Okay, and the reason why I'm not going to be showing you the live Nearpod is because I did make it student paced, so that way you guys can access it anytime instead of having to complete it while I have it open. Again, if you are going to work on the Nearpod, make sure that you click the link that is in assignments, because that one is a student paced Nearpod that you can access anytime, so whether it's open or not. All right, so are we all ready to get started? And then let's see, Anaya, can you keep an eye on the chat and make sure that I notice any questions? And if I don't notice them, unmute yourself and read it out loud. And everyone, as you are participating, please feel free to unmute yourself if you have questions. If I'm going too fast, if you have questions, oh, thank you, both of you guys. If you do have questions, feel free to unmute yourself. I'd rather that you ask them, because if you have a question, someone else probably has the same question. It's just no one wants to stop me and ask it. All right, so let's get started. So today we're working on rule 8. We finished up last class period with subtracting negative numbers, right? With the subtracting negative numbers, remember, it's kind of weird because we usually would think if we are subtracting negative numbers, we would go like more negative, right? But we need to do the opposite. We go in the opposite direction, because if we have a negative number and we subtract a positive number after, that's when we grow in value and we move right to the left. With this one, right, when we subtract a negative number, it's only in math that when we have 2 negatives, it makes it positive, right? We're not in psychology class. We are in math class. So if we have 2 negatives, it makes a positive. Okay. So now that we're done with our rules on adding and subtracting, we're going to move to multiplying. With that said, we are still going to apply a lot of our rules from adding to multiplying. And I'll show you guys why. All right, so for our same sign rule, follow along this part. I know it's easy to assume that we're going to have just all the same signs, right? Because it says same sign rule. So for our same sign rule, meaning that we have either two positives, right? A positive number times a positive number, we will get a positive product, right? We have a positive number, we multiply it by a positive number. That means that we are going to have a positive product or positive answer. But here's the doozy, okay? When I have a negative number, I multiply it by a negative number, I'm not going to get a negative answer. I'm going to get a positive. Remember, when we had two negative numbers here, we went the opposite direction on the number line, right? All right, so I'm going to show you guys here on my number line kind of how that works, okay? I have negative 2.5, and I'm going to multiply it by negative 2, okay? So typically, right, we would think like if I go step 1, I start at 0, and I move negative 2.5, right? Here's negative 2.5 times 1. Just real fast too. In math, when we multiply, now 7th graders, we know algebra, we don't see multiply as an X anymore. We will see it represented as a dot. I know it was represented as a dot in the SBAC test, and people reached out to me saying, like, what is this dot? It means to multiply, right? So if I had 6 times 5, and I use the dot, that is the same as just saying 6x5, right? It's going to be 35. The same thing can be represented as 6 times 5 with the 5 in parentheses. And the reason why we see it commonly like this with 6 and then 5 in parentheses, if you have an expression that says like 6x, and then it gives you a value for x, when you plug it in, it's represented in that way, right? You can see like that, right? But since it's a value, you put it in parentheses. So that way it doesn't look like 65, okay? So with that said, since we are 7th graders and we know algebra now, that dot means multiply. Okay, I'm going to try my hardest to only use the dot from here on out. All right, so from 0, I go negative 2.5, that's one time, and I go negative 2.5 another time, right? It's going to take me all the way over here on my number line, negative 2.5 twice, right? If I read my number line, it's going to give me negative 5, right? Negative 5, but let me think here for a second. If I did that, right, negative 2.5, negative 2 times, right? I could look at that, or I should look at that. 2.5, right? I have my negative 2 there, minus negative 2.5. Again, right? Because when we multiply, we're basically adding those two values together. If it's negative, I'm going to be subtracting it, right? So if I have these negatives here, I'm going to be doing the same rule. I need to go the opposite direction, right? Or if I'm adding with different signs, right? I know that if I'm using negative numbers, I need the absolute values. And I also do the opposite, add two negatives together. So instead of seeing this as right, I should be moving to the left. And when I move to the left, it automatically makes my numbers positive. Because two groups of 2.5 is equal to positive 5. Right, because I'm doing the same thing. I have two groups of 2.5. Right? Here's my negative 2.5 pins. All right, and I have 2.5 more negative pins. If I have two groups, right, I have 1, 2, right, here's a half. Back on, there's 3 pins, 4, 5. I have 5 pins, right, in my groups. So that I will have, using my rule, my negative times the negative, and I'm thinking them just as values, right? A distance from 0. My distance from 0 is still just 5. Right? I'm going the opposite direction on my number line. Because all multiplying is adding numbers together, right? Two groups of 2.5 is equal to the opposite of negative 5, or 5. So I know this all kind of looks really, really weird, right? And as we learn these rules, it took us a while to kind of contemplate how we went from having a negative value, right, and then turning it into an adding problem. But when we looked at it, we saw that we moved in the opposite direction, because if we moved to the left, we negative, but we were taking away from that negative value, right? So we need to do the opposite when we're multiplying. We need to do that same concept, and it will give us a positive number. This right here is just my proof that the rule applies and always stands true, right? So if I have two negative numbers, it's not going to give me a negative value. It's going to give me a positive value. Two negatives make a positive in math. So if I multiply two negatives, I'll get a positive. And I know that this rule is true. Here's my proof on the number line. And from here on out, you don't need to solve any more than just doing the multiplication problem. And I'll show you guys here. Okay, and I want you guys to just see that explanation, just so that way you don't think that I'm just like feeding you a bunch of mumbo jumbo and expecting you to believe it, right? But here's all you really have to do when you are multiplying these numbers. If you see two negatives, you know two negatives make a positive in math, right? So I have my negative 1/3. I'm going to multiply that by my negative 1/2. One other thing that I kind of just want to shed some light on, because I know that in like 5th and 6th grade, that's kind of when you learn how to multiply fractions, but we didn't really have a lot of school then, right? So when I multiply fractions, what I do is I just multiply across. And multiply my negative 1 times 1 and my 3 times 2. So I have a negative times a negative, right? Negative 1. That will give me a positive 1. And then 3 times 2 gives me 6. So my denominator will be 6. I have a positive 1, 6. Using the same sign rule, I multiplied two negative numbers, right? And then for bottom, I had two positives, 3 halves, and that gave me a positive 6. Okay, so now I have, about this box. Again, I had my same sign rule, negative times negative equals positive. Let's say that, this is just a side note, let's say that you didn't know where to put the negative sign, but you have negative 1/3 and negative half. If you would have written it as like negative 1 over positive 3, because one number has to be positive, one number has to be negative for it to remain negative, right? Let's say that I decided I wanted to put my positive on top for the 1 and have a negative 2. So that gave me a negative 1, right? If I had negative 1 times positive 1. And then I had 3 times negative 2. And I had negative 6. If I have two negatives, right, my simplified fraction, I'd pull out that negative 1. It would give me a positive, right? So if I have a negative over a negative, that means it's positive. Same concept applies here, okay? So now we're gonna, over here for our next problem, we're gonna solve here for positive 3.4 and positive 2.6. So for my same sign rule, positive times a positive, that gives me a positive, right? Same sign rule right here. So I know that since I have two positives, I'm going to have a positive product. Product just means the answer, right? When I multiply two numbers together. But just to touch on multiplying numbers with decimals, I'm going to show you how to do that just in case you forgot in 5th or 6th grade. Pandemic kind of changed things for us, right? So I have 3.4 times 2.6. So if I have 6 times 4, it's going to be 24. Carry the 2. So then I have 6 times 3. Then I need to add 2, so I have 20. And if I look here, I have 1, 2 numbers, decimal point, right? I have 2 numbers that are behind decimal point, one here, one here, so that's 2. So I know that it's going to be 2.04. Okay, that is my secret trick. I guess it's not really a secret trick, that's how you do it. But I have 2.04 that I need to now multiply this one. 0. 2 times 4 is 8. 2 times 3 is 6. I have 1, 2 numbers behind a decimal point. Right. Then I just add these together in traditional math. I have 4 plus 0, 4. 0 plus 8 is 8. Drop my decimal place down. I don't need to count anything here. I'm just adding. I'm not multiplying. Okay, and then I have 2 plus 6. This is 8. 8.84. And just as a check for yourself, if you don't remember the rule, like to think, oh, hey, I need to count these two, and that's where I put my decimal point. If I have 3 times 2, I know it's going to be greater than 3 times 2 because both numbers are greater in value, right, than just 3 and 2, except 3.4 and 2.6. But I know that my answer has to be greater than 6 because 3 times 2 is 6. But if, let's say I didn't know where to put my decimal point, if I think my answer might be 88.4, I know that if I have 3 times 2, it probably won't get anywhere close to 88, right? So what we do is double check our math. I counted how many numbers I have behind the decimal places, right? I have 1, 2, so I put my decimal place 2 over. And just in case I forgot that part, I know that my answer couldn't possibly be 88 because I have 3.4 times 2.6. Okay. So with that, I have a positive 8.4. Any questions so far? All right. There's no questions, then we're going to move on to our guided practice. Okay, I'm going to give you guys 4 minutes. After the 4-minute timer is up, what I'll do is I'll check the answers that I have in the Nearpod. As long as you submit, you get full credit. We'll go over the answers. If everyone gets them all right, I guess we don't have to go over it. But if we have multiple people missing the same ones, we will go over those. Okay, so here's our 4-minute timer. All right, guys, so we're about halfway through the timer minutes. Almost everyone has gotten number 1 correct, which is awesome. All right, guys, so we have about 15 seconds left on our timer. All right, so the timer just ended. All right, so I have here -4 times negative, there we go, times -3.75. So with my same sign rule, I see that I have 2 negatives, so I know that my answer will be what? Yep, positive. The answer will be positive since I have 2 negatives. All right, so if I have 2 negatives and multiply them together, I'm going to just negative, so 3.75 times 4. I like to set it up this way. It's just visually, it's more appealing to me, makes it easier when I multiply. So I have 4, I'm going to multiply that by 5, that's going to be 20. Carry the 2. 7 times 4 is 7, 14, 21, 28. Plus 2, that's going to give me 30. Okay. 4 times 3 gives me 12. Plus 3 is going to be 15. I have 1, 2 numbers behind a decimal point. There isn't a decimal point with numbers behind it there. So I just need 1, 2 numbers, right? Behind my decimal point. So my answer is a positive 15. And again, if I look at my numbers, I have 4 and 3. I know that my value has to be at least a minimum of 12. If I go even further, I know that it's going to be less than 16, right? Because it's not 4 times 4. I have 4 times 3.75. So my answer is positive 15. So it's the same sign rule with a negative and a negative. I get a positive. All right, so number 2. I have which two integers have a sum. We know what sum means, right? Sum is that fancy word when we added our numbers together. So I know if I add my two integers, right, and we remember what an integer is, right? We learned that in section 2. Integer encompasses whole numbers and the negative whole numbers. So I'm going to be adding two numbers together, and my answer will be equal to negative 12. And when I had adding positive or rational numbers with the same sign, if I add a positive and a positive, I'll get a positive. If I add a negative and a negative, I'll get a negative. So I know that I'll possibly have two negative numbers. But if I have a negative number that is larger than negative 12 and I add a positive number, I can still get a negative. So I know I have at least one negative number as an integer, right? Because I'm looking for the two integers that add up together to give me negative 12. Next, I have a product of positive 27, meaning that I have two integers, right? And when I multiply them, it's equal to positive 27. Since I know that I have to have at least one negative number, and here on my rule, right, if I multiply a negative and a negative together, it'll give me a positive. It definitely has to be a negative and a negative, right, for me to get negative or positive 27 if I have at least one negative number for my sum. So if I have two negative numbers to get my product, that means I obviously have to have two negative numbers for my sum, right? Because these, I'm only looking for two integers. And the sum must equal negative 12. And the word here is and. The product of those two numbers, these two, needs to equal 27 when I multiply them together. So if I have to have two negatives here, obviously these will also be two negatives because it will be the same two numbers. So just by process of elimination, knowing that I have to have two negative numbers, I can already see here that I'm not going to use, right, because it's two positives. We can get crazy right now, and I can add positive 4 plus positive 3 and know that I'm going to get 7, right? If I have the number 7, I can see that the sum will not be negative 12, right? So again, that does not work. All right, so now I see that I have 3 and 9, right? They're positive. Process of elimination, I know they should be both be negative, but just in case we want to be crazy, do the math. 3 plus 9 is equal to positive 12, which means that the sum of both integers equals negative 12. That does not hold true, right? Because this is positive. All right, so now I know that it could be A or B. Which one do you think it is? Is it A or B? All right. Calm down with that unanimous answer of A. We'll try out A. So if I have this sum of negative 2 and I add negative 6, I know that when I add rational numbers with the same sign, It's going to be negative, so I can add up the absolute value, throw on my negative sign, right? So 2 plus 6 is equal to 8. They're both negative, so it's going to be a negative, so it's negative 8. But the statement says two integers have a sum of negative 12. This does not have a sum of negative 12. If I would have multiplied them, yeah, I would have gotten negative 12, but it says the sum, right? The sum, meaning I add them. All right, so now I'm going to try out B. Process of elimination obviously says there's only one left, so it's probably the answer, but let's double check. I have negative 3. I add a negative 9. Then I add numbers with the same sign, right? Keeps its sign. So 3 plus 9 equals 12. Throw on my negative sign because they're both negative. All right, so the sum of negative 3 and negative 9 is equal to negative 12. I do, let's see, need to figure out if I get a product of 27 when I multiply negative 3 and negative 9. So negative 3 times negative 9. So let's see, if I multiply two negative numbers together, I'm going to get a positive. All right, so my answer will be positive, right? So it's looking good so far. 3 times 9, 9, 18, 27. That gives me a positive 27. So that means that I do get a product of 27 when I multiply negative 3 and negative 9. So for number 2, my answer is B. Okay. And I promise it's just practice. Like once you start recognizing that you have two negatives or two positives, you will always have a positive. All right, so which two integers have a sum negative 21? Meaning when I add two numbers together, it will give me negative 21. This is very similar to the other one, right? Anybody got questions? Thank you. All right, so if I have a negative and I add two numbers together, I know that I could add a negative, a larger negative number. If I add a smaller positive number, it could possibly be negative 21. So let's see what our and constitutes. It says a product of 108. So 108 is positive. I know that in order to get a product, I need to multiply two numbers. It's going to equal a positive. So if I know that I am going to have at least one negative, I know that using my same sign rule, I will have to have two negatives get that positive, right? Because I know over here I have to have a negative because the sum is negative 21. So I know I will have two negatives. You're funny. All right, so this process of elimination, right, we can already see that we only have one answer that has two negative numbers, right? Negative 12 and negative 9. So let's not even play around with A. If I have 3 and 7, I obviously have two positives, right? 3 plus 7 is equal to 10, right? So that won't work, right? Because the sum of the two numbers is not equal to negative 21. 3 times 7 is 21, but that's negative, right? This gives us positive answers, 10 and 8. 10 plus 8 will equal 18, right? And that is not negative 21. Right? We have 12 and 19 over here. If we add those together, we get positive 21. right? So that already tells us if I add negative 12 and negative 9, I add the 2, 12 and 9, I get 21. Throw in my negative sign because they're both negative, right? So I see here that this holds true. The sum of negative 12 and negative 9 is equal to negative 21. Okay, so now the product of my two numbers, if I have negative 12, I multiply negative 12 by negative 9. My same sign rule tells me that I will have a positive answer, and 12 times 9 is equal to 108. So with that said, D is my correct answer. I always don't want the only one with two negatives, but mathematically it does work out. Okay. All right. So now we're going to move on to section 9 if nobody has questions. Okay, perfect. No questions. Sometimes I'll scan the computer screen like I'm scanning a classroom. I know it's very weird. I'm just hoping that someone asks the question. They have it. All right. We are moving on to rule number 9. We only have 9 minutes, so we probably will not get to the guided practice. But like I said, I will put that on our YouTube channel. So if you want help on that, it will be homework, so it does need to get done. It will be on the YouTube channel. If you're already at the YouTube channel, just watch the rest of the videos, and then you'll have the extra credit for 10, 11, and 12. Just throwing that out there. Okay. So I'm going to kind of rush through this a little bit, but please, if you have questions, stop me. I would rather that I answer a question and not finish this than you guys have a bunch of questions and leave here today, okay? So different signs. I am, again, multiplying for this rule. So I'm multiplying rational numbers with different signs, right? So that means I won't have two positives. I'll have one positive, one negative. Okay? So here is my rule. Right? Different signs rule. Right? The last one was same signs rule. We had same sign. With my same sign rule, they were both positive products, right? Both positive products. So two pluses or two positive numbers makes a positive product. Two negatives makes a positive product, okay? So now we are going to throw in our negatives. If I have a positive number, I multiply it by a negative number, my negativity stays with me to my answer, right? Again, we're not in psychology class, we're in math class. I'm going to tell you to hold on to that negativity, okay? Let's look at it this way. If I have a negative number and then I multiply it by a positive number, right? We like the dots, so we're learning. If I have a negative, I multiply it by a positive, I'm going to get the same exact thing. I'm going to hold on to my negativity, and I will have a negative product. Okay? It's only math class. Everything else in life, if you have negativity, let it go. Yes, I know, I'm overly positive. All right, so if I multiply a positive and a negative number, it will give me a negative product. If I multiply a negative number with a positive number, it will give me still a negative. So different signs, right? I will always have that negative sign, right? So think about it, keep it in there. Whenever you have a negative in your, a negative mixed with a positive, you're going to carry the negativity to the product or to your answer, okay? And now that we have a number line again, we're going to do the same thing we did last time, but I don't have two negative numbers, right? So I don't have to do the opposite. It's going to just stay negative. So for the equation, negative 3.5 times 2, or we could even look at it as negative 3.5 times 2, whatever way, positive or negative first. Right, I'm going to start at 0. Right? And I have negative 3.5. See here, my numbers are divided by 2, so each little line is going to be half. So I'm going to go all the way over to negative 3, past negative 3 to the little line. Okay, so here's negative 3.5 one time, right? Or times 1. And then I'm going to go one more time, negative 3.5, right? So it's almost like I have negative 3.5 plus negative 3.5, right? And when I add rational numbers with the same sign, right, I have a negative plus a negative gives me a negative answer, right? So my negative 3.5 2 times will give me, if I read my number line, negative 7, right? And it stays just like that. There's no opposite involved because I am not going a negative 2 times, right? If I was going to do that negative 2 times, I'd go in the opposite direction. But I'm not doing that, okay? So that shows me again that if I have a negative, I multiply it by a positive, I will always get a negative number, okay?
Did you guys apply that to town about making it feel bad about
All right, so all right, so I've got 0.56. I'm going to multiply that by negative 8, meaning I have one positive number. I have one negative number. So my answer, my product, will definitely be negative. So if I have 8 times 6, that's going to give me 48. Carry the 4. 8 times 5 is 40 plus 4. So then I need to carry that 4 again. 8 times 0 plus 4 will give me 4. I have 2 numbers behind the decimal point, right? So I don't have any down here, right? There's no numbers back here. So I'm going to have 1, 2 over 4.48, right? So my answer is negative 4.48. And if I look at these, right, I have 8 times a half essentially, right? So I know that my answer should be around 4, a little bit bigger than 4, right? Because I have 0.56, so that makes sense. Just in case you don't know the decimal rule, count how many numbers you have behind the decimal point. You should know that your answer should not be larger than 8, right? So if you accidentally put your decimal place over here, it'd be really, really hard to have 8 times negative half, or negative 8 times a half equal 44, right? So there's 2 different ways. Kind of check yourself. So my first answer is negative 4.48. All right, so for my second equation, I have a negative times a positive. So if I have negative 2.6 times positive 3, I know that my answer will be negative, right? Because it's the different sign rule. Negative and positive equals a negative. I'm going to multiply those. 3 times 6 is 18. Got 8. Carry the 1. 3 times 2 is 6 plus 1 gives me a 7. Right here is my decimal point. So I have 1 behind the decimal point. I don't have a decimal point or any numbers that follow for the bottom number. So that means I just need 1 number behind my decimal point. That puts me right here at 7.8. Right, and if I have 2 times 3, I know that my answer has to be greater than 6, right? Because 2 times 3 is equal to 6. 2.6 is a little bit larger than 3, so I know that it has to be less than 3 times 3, right? So it has to be less than 9. Negative 7.8. All right, so I know I only have 1 minute. Please bear with me. I have a negative right here. I'm multiplying more than 2 rational numbers, right? So if I have, like this example, 3 numbers, what I want you guys to really know is that I can break that down. I don't have to multiply them all at the same time. So if I chunk it into 2 different problems, right, I'm going to take my first 2 numbers. I have negative 1/2, right, and I'm going to multiply that by negative 2/3. Right? When I multiply fractions, I just multiply straight across. This is equal to negative 1 times negative 2. That means I need to use the same sign rule again. But I have a negative and a negative. That will give me positive 2, right? And 2 times 3 is equal to 6. So now I have positive 2/6, and I have 1 fraction remaining, right? I have this negative 3/5. So I need to take the 2/6 and multiply that product by negative 3/5. When I do that, that's going to give me 2 times negative 3, which is multiplying 2 different signs, right? So I will have a negative 6. Then I have 6 times 5. So I have negative 6 over 30, right? And that is my answer. So even though I have all the same signs right here, negative, 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 when I multiply the negative and a negative, I will get a positive, right? And so when I multiply this positive by a negative, it's going to give me negative 6/30. So my final answer here is negative 6 over 30. So make sure you fully understand and recognize your different sign rule and your same sign rule. And you apply those as you go through the math. Kind of like how our practice for section 7 was kind of like all the rules that we had before, and we had to apply them to the word problems. Okay, and I know that we went over. I can't believe all of you guys stayed. Thank you so much. You guys are the best. With that, our homework is just the guided practice for 9, and you will get extra credit for doing 10 and 11. I know it's 122. You guys are the best. I appreciate you all. And I'm glad that you didn't catch that I went overtime until I said I went overtime. Those guys weren't staring at the clock to get out of here. And then I hope that I get to see all of you on Thursday. I'll see you guys next week. Please reach out if you have any questions about makeup work. I can help you. The YouTube channel is in the chat. Let me see if I go up enough, if I can find it. We talk too much in this class. All right, here's the YouTube channel. This is where you will find all of the videos of the class recordings. So that way you can do your Nearpods, okay? All right, bye. All right, bye. All right, guys. Have a good rest of your day. Have an amazing weekend, and I will see you guys next week. Bye, Anaya. Bye, DeMarcus. Bye, Kevin. Bye, Leonidas. Bye, Janelle. Bye, Evie. Bye, Alyssa. All right. Any more questions? All right, I'll go ahead and end the meeting, and I'll see you guys later. Unless you guys have questions, you need to call me.